At 10:01 in the morning, Moscow time on December 27th, the largest New Year's celebration in the Russian capital collapsed into darkness in a single heartbeat, transforming a sea of neon lights into a frozen silhouette against the winter sky. One moment, the festival radiated confidence and abundance, a carefully staged promise that everything was normal. The next moment, the lights vanished, the music died mid-note, and the illusion shattered. This was not a random outage or seasonal malfunction. It was the opening signal of a deliberate operation designed to strike Moscow's power system at the most symbolically sensitive moment of the year. The location could not have been chosen more carefully. The sprawling exhibition complex near the Kremlin served as a visual anchor for state optimism, with an ice rink larger than many sports stadiums and a towering New Year tree meant to dominate television broadcasts. Late December, temperatures hovered well below freezing, amplifying the emotional impact of sudden darkness and silence. While crowds gathered to celebrate, the site also stood only a short distance from military facilities and command centers, making it a perfect psychological pressure point rather than a purely civilian inconvenience. The blackout narrative framed the event as a response rather than an initiation. Ukrainian infrastructure had endured repeated attacks on its electrical grid, and this strike inverted that logic by demonstrating vulnerability at the heart of Russia's most protected city. The message was not hidden in rhetoric, but encoded in timing, location, and scale. By striking during a national holiday built around enforced optimism, the operation targeted public perception as much as physical systems, challenging the idea that Moscow existed beyond the reach of retaliation. To understand how the lights went out so abruptly, the story shifts away from illuminated plazas to a stretch of snow-covered forest in Lasany Ostrov National Park, northeast of the city. There, a 6-person Ukrainian intelligence team operated with minimal movement and no electronic chatter, working in temperatures that punished exposed skin within minutes. Their objective was not spectacle, but precision. Everything about the environment had favored agents, concealment, and patience, the same qualities required for what was about to unfold. The team had brought no traditional aircraft, no piloted platforms, and no expensive stealth jets. Instead, they relied on 2 Dovebush T-10 unmanned aerial vehicles, purpose-built carbon fiber platforms designed to appear unremarkable to radar systems tuned for heavier threats. Each mothership carried 6 Wasp first-person view attack drones, compact, expendable, and optimized for one-way missions. The design philosophy favored asymmetry, using low-cost materials, unconventional profiles, and careful planning to challenge systems worth billions. The Dovebush airframes were engineered to exploit perception. Their composite construction and shape produced a radar return comparable to that of a large bird, allowing them to blend into background clutter. With a wingspan measured in the low double digits and a mass light enough to remain airborne at modest speeds, they were never meant to outrun defenses. Instead, they were built to avoid being noticed at all, especially in a city where radar screens constantly filtered out false contacts from wildlife and urban interference. Each mothership carried its payload beneath the wings. 6 Wasps per aircraft, mounted in a way that minimized drag and preserved stability. The Wasps themselves were simple by design but lethal in purpose, each equipped with a shaped charge intended for infrastructure targets rather than armored vehicles. Their mission profile emphasized accuracy over survivability, accepting losses as part of a larger calculation. This acceptance of attrition was not recklessness but a core element of the plan. Moscow's air defense network presented the central obstacle. Layers of systems surrounded the city, with Pantsir S-1 batteries forming a dense inner ring. These systems could track hundreds of contacts and engage multiple targets simultaneously, but they relied on finite resources. Missile magazines were limited, reloads took time, and cannon barrels overheated under sustained fire. For Ukrainian planners, the defenses were formidable but predictable, governed by physics, logistics, and human fatigue. The plan combined several techniques into a single sequence. Terrain masking along the Yoza River kept flight paths low and irregular, exploiting radar blind spots created by buildings and power lines. Decoy drones constructed from lightweight materials and simple reflectors were introduced to overload detection systems, mimicking the signatures of more dangerous threats. Timing was critical, chosen to coincide with late-night complacency and holiday distractions within defensive crews. Shortly before 10 in the evening, the first Dovebush launched, its departure marked only by the soft, mechanical click of a catapult system locking into place. Operators saw what appeared to be a sudden surge of incoming objects, forcing rapid engagement decisions. Missiles launched in quick succession, each intercept costing more than the entire attacking package. While attention focused on the apparent swarm, the real payload moved unnoticed, closing distance toward critical electrical infrastructure that powered the city's most visible celebration. This was only the opening movement. Losses were expected, and the defenders would adapt quickly once the deception became clear. What mattered was not the success of every drone, but the gradual erosion of certainty and capacity within the defense network. As the first wave pressed forward and the city's sensors filled with noise, the conditions were set for a second act that would exploit every response Moscow had just revealed. As the first wave unfolded, the defenders believed they were regaining control. Several incoming objects had been destroyed, cannon fire traced bright arcs through the night, and electronic countermeasures began to saturate the airwaves. From the Russian perspective, the engagement looked messy but manageable, the kind of chaotic encounter that ended with reports of averted disaster. Inside command posts, the initial assessment leaned toward confidence, reinforced by the assumption that any remaining disruption would be local and temporary. That confidence rested on a misunderstanding of intent. The Ukrainian team had never expected the first wave to finish the job. It existed to drain attention, heat metal, and force premature conclusions. Every missile fired, and every burst of cannon fire narrowed the options available for what followed. The defenders were solving the wrong problem, focused on visible threats rather than the invisible logic shaping the engagement. As the surviving wasps from the first release descended into the urban maze, losses mounted exactly as anticipated. One drone disintegrated under concentrated 30mm fire, its fragments scattering harmlessly across rooftops. Another was crippled by small arms, spiraling into signage before detonating without effect. A third mistook the thermal glow of industrial exhaust for its target, slamming into brick and leaving only scorch marks. Each failure reduced numbers, but none altered the plan. The remaining drones had exploited the chaos their predecessors created. Smoke, debris, and tracer fire disrupted visual tracking while radar systems struggled to differentiate targets from background noise. In those seconds, speed mattered less than geometry. One wasp slipped past perimeter fencing and struck a 20-kilovolt bus bar with precise alignment, triggering a flash of blue light that briefly illuminated the skyline. The effect was real but incomplete, a partial disruption that suggested inconvenience rather than catastrophe. On the ground, Russian crews interpreted the flash as a contained incident. Power fluctuations were logged, technicians alerted, and early messages framed the situation as a minor technical issue. That interpretation mattered more than they realized. Believing the threat neutralized, defensive posture relaxed just enough to open a window that had been calculated from the beginning. Roughly 10 minutes after the first engagement began, the second Dovebush approached from a different vector, its route chosen to exploit known coverage gaps revealed moments earlier. The timing aligned perfectly with the defensive reload cycle. Missile rails sat empty, loader vehicles were still repositioning, and cannon barrels glowed from sustained firing, forcing crews to pause or risk permanent damage to their own systems. This second approach was quieter, but not uncontested. Russian forces escalated their response by deploying additional electronic warfare assets, including a mobile Krasuka-4 system positioned to blanket control frequencies with noise. Handheld jamming weapons joined the effort, their operators scanning the sky from rooftops and bridges. The airspace over the river corridor became a hostile electromagnetic environment designed to sever every possible link between drone and operator. The first drones of the second wave paid the price. One lost its video feed instantly, drifting into a residential building before exploding harmlessly. Another succumbed to directed jamming, its control logic collapsing as it plunged into frozen water. From a distance, these outcomes looked like confirmation that the defenses had adapted and overcome the threat. What followed challenged that assumption. With external links severed, the remaining WASPs transitioned automatically into autonomous mode. Their onboard processors compared live visual input against a preloaded three-dimensional model of the city, navigating by geometry rather than signals. Street patterns, light clusters, and building outlines became reference points. The drones no longer needed instructions, they only needed time. Realizing the drones were still advancing, Russian commanders activated a final reserve. A Tor M2 system, held back to protect the most sensitive assets near the Kremlin, came online and launched interceptors at targets now closing rapidly. One drone was shredded by proximity detonation, tungsten fragments tearing it apart mid-air. Another climbed deliberately, drawing fire and absorbing the last ready missile in a calculated sacrifice. The remaining pair pressed on, their paths masked by smoke and confusion. Ground fire intensified, rifles and machine guns filling the air with lead. One drone took a fatal hit to its power system, but carried forward on momentum, crashing into a backup generator fuel tank. The resulting fireball obscured the approach of the final WASP, hiding it in heat and flame. With only seconds remaining and minimal battery power, the last drone locked onto the primary transformer assembly. It identified the precise point where oil lines entered the pressurized casing and initiated a terminal dive. Circuit breakers tripped in sequence, cascading failure outward through the grid as protections sacrificed themselves to prevent wider destruction. Back at the festival grounds, the effect arrived without warning. Lights surged once with blinding intensity, filaments burning out as screens went black and music cut off mid-phrase. The towering tree flickered, then vanished into darkness. In the freezing silence that followed, the message was unmistakable. The night itself seemed to absorb the sound, leaving only cold and uncertainty where certainty had been staged. In the minutes following the blackout, confusion rippled through Moscow's emergency systems. Automated diagnostics reported faults cascading far beyond the original substation, while operators struggled to reconcile sensor data with visual reality. From the outside, it appeared as though a single transformer failure had somehow propagated through layers of redundancy designed to prevent exactly this scenario. Inside control rooms, the discrepancy between expectation and outcome slowed response, buying precious time for the attacker's intent to fully register. What made the failure so disruptive was not just the explosion itself, but the way it forced protective systems to behave. High-voltage grids are engineered to sacrifice components in a specific order, isolating faults to preserve the larger network. In this case, the internal bolted fault created by the shaped charge overwhelmed those assumptions. Protective relays tripped faster than crews could react, and by the time manual overrides were attempted, the damage path had already locked in. As technicians mobilized, the political dimension began to assert itself. Initial statements framed the outage as a minor technical glitch, an inconvenience quickly addressed. That framing mattered because it delayed acknowledgement of deeper damage and discouraged immediate escalation of repair resources. In a system strained by sanctions and limited access to specialized components, time lost translated directly into prolonged darkness. From the Ukrainian perspective, the operation had already achieved its core objective. The strike was never about permanently disabling Moscow's grid, but about demonstrating precision, reach, and timing. By forcing the Kremlin to choose between admitting vulnerability or maintaining an increasingly implausible narrative of control, the blackout imposed costs far beyond physical repairs. Every minute without power at the city's most visible celebration amplified the psychological impact. The economics of the exchange underscored that asymmetry. The attacking force committed 2 Dovebush motherships and 12 Wasp drones, a package valued at roughly $60,000. In response, Russian defenses expended at least 15 interceptors, each costing close to $1 million, along with thousands of rounds of cannon ammunition and the operational life of overheated components. The imbalance was stark and intentional. Repair crews faced additional constraints. The damaged transformer was not an off-the-shelf component, but a specialized unit requiring parts subject to export controls. Even with immediate authorization, sourcing replacements would take weeks or months, forcing engineers to rely on temporary configurations that reduced grid resilience. Every workaround increased vulnerability to future disruptions, compounding the strategic effect of a single strike. Satellite-based thermal monitoring added another layer of exposure. Independent fire detection systems recorded a pronounced heat signature at the substation site, contradicting claims of a trivial incident. These data points circulated quickly, shaping external perception and limiting the effectiveness of official messaging. In modern conflict, controlling the narrative requires more than statements when independent sensors tell a different story. Within Moscow, the blackout reshaped the atmosphere of the holiday itself. New Year's celebrations are not merely festive events, but ritual affirmations of stability and continuity. Interrupting them struck at a deeply embedded cultural expectation. The sudden absence of light and sound in extreme cold replaced enforced optimism with unease, reinforcing the sense that distance from the front lines no longer guaranteed insulation. For air defense planners, the engagement prompted uncomfortable reassessment. The Pantsir systems had functioned as designed, yet design assumptions proved exploitable. Magazine limits, reload cycles, and thermal constraints on gun systems became liabilities when confronted with layered deception and persistence. The Tor system, held back as a final safeguard, performed effectively but could not compensate for earlier depletion. Electronic warfare units faced similar conclusions. Jamming succeeded tactically, destroying individual drones, but failed strategically once autonomy replaced connectivity. The encounter highlighted a growing challenge. Countermeasures optimized for disrupting control links lose effectiveness against platforms capable of independent navigation. The more defenders jammed, the more they revealed about their own thresholds and coverage gaps. Inside Ukrainian planning circles, the operation validated a doctrine built on calculated sacrifice. Losses were accepted as data points rather than failures, each revealing defensive behavior and informing subsequent moves. The willingness to trade expendable systems for insight transformed attrition into intelligence, a feedback loop that favored adaptability over brute force. As dawn approached, the physical damage remained localized, but the conceptual damage spread. The idea of an untouchable capital had been punctured not by overwhelming force, but by timing, creativity, and a precise understanding of systems under stress. The blackout became less a technical incident and more a reference point, cited in discussions far removed from the frozen festival grounds. By the time power was partially restored, the symbolic damage could not be reversed. Images of the darkened festival grounds had already circulated, contrasting sharply with years of carefully curated visuals meant to project abundance and security. The interruption lingered in public memory, not as a blackout measured in minutes or hours, but as a moment when certainty fractured. In conflicts defined by perception as much as territory, that fracture carried weight beyond kilowatts lost. Strategically, the strike reframed assumptions on both sides. For Russia, it underscored that defensive density alone does not guarantee protection when attackers choose time and place with precision. Concentrating assets around the capital created a tempting focal point, but it also increased the payoff for even limited success. Every additional layer of defense added complexity, and complexity created seams that could be exploited by smaller, more agile systems. For Ukraine, the operation reinforced the value of integration across domains. Intelligence, engineering, and tactical execution aligned in a way that maximized impact while minimizing exposure. The use of low-cost platforms did not signal desperation, but confidence in a model that prioritized iteration over preservation. Each mission refined assumptions, improving the odds of future success even as individual assets were expended. The narrative surrounding the blackout evolved quickly. Initial dismissals gave way to quieter acknowledgments within technical circles that the damage was neither trivial nor easily dismissed. Engineers spoke of cascading effects and the challenges of stabilizing a grid under constrained conditions. Security analysts noted the implications for other urban centers relying on similar defensive architectures. The incident became a case study rather than an anomaly. International observers drew their own conclusions. The engagement illustrated how modern conflict blurs lines between military and civilian infrastructure without requiring mass destruction. Precision strikes against critical nodes created outsized effects, forcing difficult choices about resource allocation and escalation. The cost asymmetry challenged traditional deterrence models that assumed superiority through expenditure alone. Within Moscow, the cultural resonance of the New Year blackout lingered. The holiday represents renewal and continuity, a state-sanctioned pause where optimism is not optional. Interrupting that ritual, even briefly, disrupted a narrative reinforced annually. The cold darkness served as an unspoken reminder that war's reach extended further than many had believed, regardless of official assurances. From a technical standpoint, the engagement highlighted an emerging pattern. Air defenses optimized for intercepting aircraft and missiles struggled against swarms designed to provoke overreaction. Electronic warfare systems excelled at disrupting links, but faltered when autonomy replaced connectivity. Each countermeasure invited adaptation, creating a cycle where innovation outpaced static solutions. The transformer itself became emblematic. A single component, protected by layers of policy and hardware, failed in a way that triggered disproportionate consequences. Its destruction was not about denying electricity indefinitely, but about revealing dependency. Modern cities function as tightly coupled systems, and targeted disruptions can reverberate far beyond their physical footprint. As analysts reconstructed the sequence, the importance of timing stood out. The choice of date, hour, and sequence aligned operational effectiveness with symbolic resonance. The strike did not coincide with maximum grid load or severe weather, but with maximum visibility. In doing so, it leveraged attention as a force multiplier, ensuring the event resonated well beyond technical circles. The broader implication was clear. In an era of ubiquitous sensors and rapid information flow, no incident remains isolated. Satellite imagery, social media, and independent monitoring collapsed the gap between occurrence and awareness. Attempts to contain narratives faced structural limits, especially when physical evidence contradicted official statements. For those studying the conflict, the blackout joined a growing list of moments that illustrated a shift in warfare's character. Expensive platforms remained powerful, but their dominance was no longer absolute. Adaptability, data-driven planning, and willingness to accept losses defined success more reliably than sheer scale. As winter deepened, the memory of darkness at the heart of celebration persisted. The strike did not end the conflict, nor was it intended to. Instead, it served as a demonstration, a reminder encoded in cold allowance that assumptions could be challenged and symbols disrupted. In that sense, the operation achieved its purpose long after the lights flickered back on. At 11 p.m. Moscow time on November 8, 2025, air raid sirens tear through the western suburbs of the Russian capital, not as a drill, not as a warning from some distant front, but as an immediate reaction to something Russian radar operators are struggling to process in real time. Dozens of fast-moving contacts appearing almost simultaneously on scopes that until moments ago showed nothing but clear air, and for the crews inside hardened command bunkers. This is not confusion, but insult. Because just hours earlier, the same system had been used to plunge Kiev into darkness while Russian television hosts celebrated the strike, as proof that escalations still belong to Moscow, unaware that celebration itself had already triggered the response, now racing toward them. 6 hours earlier, as Russian missiles and drones struck Ukraine's power grid and left millions without electricity for half a day, Ukrainian planners were not reacting in panic, but confirming assumptions. Watching Russian media broadcasts, not for propaganda, but for timing cues. Because the strike was never meant to be answered immediately. It was meant to be answered when Russian confidence peaked, when air defense crews relaxed after a successful operation, and when command structures assumed the night would pass quietly. A miscalculation that began forming the moment Moscow allowed itself to celebrate on camera. Long before the sirens sounded, a Ukrainian Special Forces cell had already crossed the point of no return, positioned roughly 15 miles from Moscow in terrain chosen for its invisibility rather than its proximity, operating from what looked like an aging civilian cargo truck parked where no one would remember it twice. A vehicle that had passed police checkpoints, cameras, and routine scrutiny precisely because it looked unimportant. And inside it were not soldiers preparing for a firefight, but operators preparing to turn air defense doctrine against itself, using patience rather than firepower. At 10:45 p.m., with the city still glowing normally and no public indication of threat, a side panel slid open just enough to vent cold night air, illuminating the interior with the muted green light of ruggedized screens. And without ceremony, the first of dozens of Calibri FPV drones were launched by hand, not fired, not catapulted, but released gently into the air where they hovered briefly, stabilizing, synchronizing, and organizing into a loose formation that had nothing aggressive about it yet. A deliberate choice meant to delay detection and prevent premature reaction. These drones were not designed to survive, and survival was never part of their mission profile, because the goal of the first wave was never to strike infrastructure or people. It was to provoke decision-making at the highest defensive layer, the one Moscow trusted most, the long-range S-400 system built to counter strategic bombers and cruise missiles, not low-cost improvised aircraft. And the planners knew that Russian doctrine would compel those systems to respond aggressively once the drones crossed a predefined engagement line. At exactly 11 p.m., the drones crossed that invisible boundary, and the reaction was immediate, with S-400 operators locking targets that appeared clumsy and unrefined compared to the threats they were trained for. Yet doctrine left little room for restraint, because allowing any unknown aerial object to proceed toward Moscow was unacceptable, and so orders were issued without hesitation, launching 40 N6 interceptors whose individual costs exceeded the combined value of entire drone clusters, a response that felt decisive, powerful, and correct to the crews firing them. Within seconds, half the drones vanished from radar, erased by blast waves engineered to destroy high-speed aircraft. And inside Russian command rooms, the initial assessment was already forming, that the threat had been exaggerated, that the defense had worked, and that the attackers had wasted their effort. But in a separate Ukrainian command cell, those same radar losses were being marked not as failure, but as confirmation. because the most expensive layer of Moscow's defense had just been forced to expend irreplaceable assets on disposable targets. The surviving drones did not retreat or scatter. They continued forward at deliberately chosen speeds, now entering the engagement envelope of Pantsir S-1 systems positioned to handle precisely this kind of threat. And it was here that the operation shifted from provocation to deception, as Ukrainian operators activated software profiles that altered each drone's electronic signature in real time, transforming simple FPV platforms into radar ghosts that resembled cruise missiles or low-flying helicopters, depending on angle and range. For Panzer crews, the change was instantaneous and deeply unsettling, because the situation no longer resembled a nuisance swarm but a coordinated strike package, and the system's algorithms elevated the contacts to high priority faster than human operators could question the data, triggering automatic responses reinforced by months of warnings about surprise attacks. And so missile after missile was launched at targets that existed only as mathematical constructs inside a radar processor, burning through stockpiles in under 2 minutes. As the last Calibri drone was destroyed, Russian screens cleared, and a sense of relief spread quickly through the chain of command, reinforced by internal reports and public statements declaring the attack neutralized. Yet the silence that followed was not peace but exposure, because while operators focused on reloading launchers and resetting systems, they remained unaware that the real attack had already been airborne for hours, moving quietly along a route no one was watching. That second wave consisted of Liuti drones launched far earlier from outside the immediate battle space, flying low enough to remain beneath radar horizons while using oil pipeline corridors as navigation references, a method chosen not for speed, but for certainty, because terrain does not jam and pipelines do not move. And by the time the first wave was declared defeated, these drones were already approaching their climb points, waiting for the moment when Moscow's defenses were most vulnerable. As Panzer crews worked to reload and rearm, their sensors lit up again, not with scattered contacts, but with a dense cluster emerging from the west, larger, more capable, and arriving together. And in that moment, the mood inside Russian command bunkers shifted from triumph to dread, because the pattern was now unmistakable. The first wave had not been an attack at all, it had been a doorbell, and whatever was coming next was already too close to stop cleanly. With the Panzer batteries still cycling reload sequences, responsibility for Moscow's immediate defense shifted to Tor, M2 systems positioned as the final mobile layer, platforms designed to intercept faster and more robust targets at close range. And when the 60 Liuti drones broke formation and scattered, each following a chaotic flight path calculated by a shared mesh network, the engagement transformed into a brutal contest of mathematics, reaction time, and magazine depth, where every intercepted drone bought seconds but consumed resources that could not be replenished quickly enough to meet what was unfolding. Inside Russian command vehicles, operators watched targets split, merge, and diverge across their displays in patterns that did not resemble traditional attack profiles, because the drones were no longer being flown as individuals, but as a collective system that continuously reassigned roles and trajectories, mimicking natural swarming behavior rather than military formations. And this forced Tor crews into rapid-firing sequences that achieved impressive kill rates, while steadily eroding the defensive margin that Moscow relied upon to maintain confidence. Missiles launched in disciplined salvos, and one by one the Liuti drones were destroyed in mid-air, their thermal signatures flaring briefly before vanishing. And for a moment it appeared the defense might hold after all, as Ukrainian operators watched their numbers collapse from dozens to a handful in under 2 minutes, a loss rate that would have doomed a conventional strike. Yet the planners had always anticipated this phase as the point where Russian escalation would peak. That escalation arrived in the form of the Krasuka-4 electronic warfare system, a brute force instrument designed to dominate the electromagnetic spectrum rather than finesse it. And when it activated, the effect on Ukrainian control feeds was immediate and violent, with video streams dissolving into static and telemetry collapsing across multiple channels, disabling the majority of remaining drones in seconds and creating the illusion that the swarm had finally been broken. From the Russian perspective, this was the decisive moment. The confirmation that technological superiority still mattered because the electronic attack should have rendered any remotely piloted system blind and uncontrollable. Yet what followed violated expectations formed by decades of doctrine, as the drones did not tumble or scatter, but continued forward, maintaining spacing and direction despite the loss of external control, a behavior that forced Russian operators to confront a threat model they had not fully internalized. The reason lay in architecture rather than hardware, because the swarm's decision-making no longer resided on the ground, but within the airspace itself, distributed across autonomous nodes, sharing inertial data, last known positioning, and relative motion, allowing the group to function even when cut off from human input. A design choice meant specifically to survive the exact scenario now playing out over Moscow's outskirts. As jamming continued without visible effect, Russian crews expended their remaining missile inventories, attempting to intercept drones that no longer responded predictably, and when the final smart interceptors were fired, the defense collapsed inward to its most primitive layer, relying on 30mm cannons positioned near residential zones and industrial corridors, weapons optimized for volume rather than precision, and whose effectiveness depended on saturating the air with metal. The night erupted with tracer fire as rotating cannons carved bright arcs through the sky, forming temporary walls of steel that shredded 4 of the 6 remaining drones over wooded areas near Kapavna, their fragments scattering harmlessly into forested ground, a result that reinforced Russian confidence even as it masked the significance of what had already slipped through. The remaining 2 drones were damaged but intact, trailing smoke and shedding components as they crossed into the final approach zone. Their guidance systems degraded but functional enough to maintain heading, and as they cleared the last defensive perimeter, their targets resolved not as symbolic landmarks, but as carefully selected nodes whose disruption would cascade far beyond the point of impact. One drone descended toward the fuel-pumping infrastructure serving Sheremetyevo International Airport, while the other tracked toward the Transneft pipeline hub in Zelenograd. Choices dictated not by destructive potential, but by systemic leverage, because neither target required total destruction to produce outsized consequences, only interruption at precisely the wrong moment. As cannon fire intensified, both drones were struck repeatedly within seconds of reaching their terminal dive, and rather than detonating dramatically, they disintegrated under the impacts, their warheads and structural mass converting velocity into force as debris rained downward. A kinetic effect underestimated by defenders who measured success purely in interception percentages rather than outcome. At the airport, falling wreckage struck the primary pumping station feeding jet fuel storage tanks, igniting a localized fire that immediately triggered automated safety protocols, shutting valves, deploying suppression systems, and halting all refueling operations, while in Zelenograd, debris ruptured a secondary pipeline feeder, igniting a contained leak that forced emergency isolation of an entire section, moving hundreds of thousands of barrels daily. For several minutes after the final impacts, the city was quiet again, sirens winding down and command rooms exhaling in relief, with internal reports emphasizing that nearly all hostile targets had been destroyed. Yet the real effects were only beginning to surface, unfolding not as explosions but as delays, shutdowns, and uncertainty spreading outward through systems that depended on uninterrupted flow. At Sheremetyevo International Airport, the immediate response looked orderly, almost routine, as automated systems did exactly what they were designed to do: sealing valves, flooding compartments with suppressant foam and isolating the damaged pumping station from the larger fuel storage network. Yet this technical success masked a deeper problem, because modern airports do not function on redundancy alone, but on timing. And within minutes, the absence of fuel flow began cascading through departure schedules, crew rotations, and inbound flight planning across multiple regions. Aircraft already taxiing were halted, others were redirected to remote stands, and incoming flights were forced to divert or hold, not because runways were damaged, but because refueling could no longer be guaranteed, grounding the entire operation for hours and creating knock-on delays that would ripple through European airspace well into the following day. An outcome far more disruptive than a cratered runway and far harder to explain away at Bosan as a contained incident. At the Transneft hub in Zelenograd, engineers confronted a different but equally destabilizing scenario. As emergency protocols shut down pipeline sections to prevent escalation, freezing oil movement through a network calibrated for continuous flow. And although the rupture itself was limited, the loss of throughput compounded over time, interrupting distribution schedules and forcing contingency measures that exposed how little slack existed in a system built for efficiency rather than resilience. Inside Russian command centers, the metrics initially looked reassuring, showing that approximately 98% of inbound drones had been neutralized, a figure that would traditionally signify overwhelming defensive success. Yet, as reports from civilian infrastructure operators accumulated, the disconnect between interception statistics and strategic effect became impossible to ignore, revealing that the operation had never been about saturation or destruction, but about selective friction. This realization arrived too late to influence the outcome, because the drones that mattered most had already completed their function by failing in the right places, transforming debris into a tool rather than a liability, and reframing the concept of success away from explosive yield toward kinetic disruption, a shift that challenged assumptions embedded deep within air defense, planning, and public messaging alike. In Moscow itself, social media filled the narrative gap faster than official statements could, as images of smoke plumes and stalled terminals spread alongside videos of air defense fire mislabeled as fireworks, undermining attempts to project control and forcing authorities to acknowledge impacts that could not be hidden without eroding credibility further. A dynamic that amplified psychological pressure far beyond the physical footprint of the strikes. For Ukrainian planners, this reaction validated months of modeling that treated information effects as equal to material damage, recognizing that striking a capital city's sense of normalcy required far less force than striking its structures, and that the true vulnerability lay not in defenses, but in expectations cultivated by repeated assurances of invulnerability. The operation also carried historical weight, recalling an earlier drone incident that had reached the Kremlin itself, an embarrassment that prompted massive investment in layered defenses and rooftop systems across government districts, measures that created an impression of impenetrability without fully addressing adaptive threats designed to bypass rather than breach those layers. By exploiting procedural rigidity instead of technological gaps, the attackers demonstrated that complexity can become a liability when it narrows response options because each defensive layer behaved exactly as designed. Yet the sum of those correct behaviors produced a strategically unfavorable outcome, a paradox that defenders struggle to reconcile in post-action assessments. Economically, the imbalance was stark as analysts began estimating costs not just in missiles fired, but in lost revenue, disrupted logistics, and emergency response, accumulating figures that dwarfed the resources required to execute the operation itself, reinforcing the asymmetry that had guided Ukrainian decision-making from the outset. While Russian officials emphasized resilience and recovery, international observers focused on precedent, noting how a limited number of low-cost platforms had forced the activation of some of the most advanced systems available, exposing a mismatch between investment and adaptability that could not be corrected quickly or cheaply. Within hours, discussions emerged among allied governments about the implications for future conflict, particularly the demonstrated value of autonomous coordination and deception in contested airspace. Themes that had been theorized extensively, but rarely illustrated so clearly in a real-world scenario involving a heavily defended capital. The significance of the night lay not in what was destroyed, but in what was revealed. That defensive dominance measured in hardware and budgets could be unsettled by strategy and timing, and that the balance between offense and defense had shifted further toward those willing to design operations around human behavior as much as technical capability. As daylight approached, a clearer accounting of the night began to emerge. Not from battlefield reports, but from spreadsheets and balance sheets, where the cost of defending Moscow was tallied in expended interceptors, emergency shutdowns, lost throughput, and disrupted schedules, adding up to a figure approaching $250 million when combining the original strike on Ukraine's power grid, the defensive response over the capital, and the downstream economic losses triggered by precautionary closures and halted transport. In contrast, the resources committed by Ukraine were modest by design, centered on a small special forces element, commercially derived airframes adapted for single use, and software development that prioritized resilience over performance, bringing the total operational cost to roughly $2 million, a disparity that transformed the engagement into a case study of return on investment rather than a traditional exchange of firepower. This imbalance reframed the night as an exercise in asymmetric warfare economics, where success was measured not by territory gained or structures destroyed, but by forcing an opponent to spend disproportionately to preserve an image of control, an outcome that strained not only budgets, but strategic narratives built on deterrence and technological superiority. International reaction followed predictable lines but carried new urgency, as policymakers and analysts across Europe cited the operation when discussing additional support for Ukraine's drone programs, pointing to the effectiveness of adaptive systems against layered defenses and reinforcing arguments that innovation and integration could yield results unattainable through scale alone. For Russian planners, the challenge was more complex because reinforcing defenses further risked repeating the same pattern, adding layers that attackers could study and exploit, while reducing coverage or restraint risked political fallout, leaving decision-makers caught between visible strength and functional vulnerability in an environment where perception mattered as much as capability. The operation also highlighted the limits of electronic warfare when confronted with distributed autonomy, demonstrating that jamming and spoofing, while powerful, were not universal solutions, and that systems designed to fail gracefully rather than catastrophically could absorb attacks that would have crippled more centralized architectures. In military academies and research institutions, the events of November 8th began appearing in lectures and briefings, not as a cautionary tale about drones alone, but as an illustration of how doctrine, incentives, and human factors interact under pressure, shaping outcomes more decisively than raw specifications. The choice to accept a 98% interception rate while aiming for a 2% effect underscored a philosophical shift in planning, where minimal penetration could still achieve maximal disruption if aligned with systemic vulnerabilities, a concept that challenged traditional metrics used to assess defensive success. By avoiding mass casualties and focusing on infrastructure interfaces, the operation also limited escalation pathways while delivering a clear message that distance and depth no longer guaranteed insulation from conflict, and that capitals could be reached indirectly without breaching their most visible defenses. In the days that followed, Moscow resumed normal operations. Flights departed, pipelines flowed, and public attention moved on. Yet the memory of sirens and shutdowns lingered, altering risk calculations quietly and persistently, the kind of effect that could not be undone by repairs or announcements. For Ukraine, the strike reinforced a strategic identity built around adaptability and precision, proving that constraint could be a source of creativity rather than weakness, and that shaping an adversary's choices could be more powerful than confronting them directly. The broader lesson extended beyond any single conflict, pointing toward a future where warfare increasingly rewards those who can integrate technology, psychology, and timing into coherent strategies, and where victory may depend less on what is destroyed than on what is forced to stop working, even briefly.